That brings us to one of the major staples of the class, the first derivative test. It kind of already makes sense based on what we've learned, but I'll read it off anyway. If the first derivative, in other words, the slope of the graph, changes from negative to positive at a point called C. I'm going to draw a picture of this. Let's see, I'm just kind of over here. And along the x-axis at some random place, I decided to call that C. All right, and C, I'm going to put a little dotted line going up and down. I like how it sounds. Okay, let's say that once I hit C, the derivative, f prime of x, also known as the slope of the graph, changes from negative, which means you were falling, and now it's positive slope, positive derivative, which means now you're rising. Well, heck, it should be obvious that you had to have a min, a relative min. We don't know if it's an absolute min because this graph could have been lower some other place, but at least right here at C, if the derivative or the slope changes from negative to positive, you have a relative minimum. And of course, the same is true for relative max. Let's say you were coming at C from the left, and your slope or derivative was positive. That means you had to be rising. But then suddenly, after you passed C, the slope became negative. Well, then you'd have to fall, or you have to decrease. It should make sense that right at x equals C, you've got yourself a maximum. So that's just the first derivative test, and we use that all the time. In fact, really, I've used it already. I just haven't called it by name, and now we're going to use it for real. All right, we're going to use this brand new first derivative test to find all relative extrema, which are the maxes and the mins. And we don't have to state whether they're absolute or local here. We'll start by taking the first derivative. F prime of x will be 8 minus x. Easy enough. If you set that equal to 0, I don't think it's too hard to see that x will come out to be 8, which is the critical number. So I'll go ahead and make my sign chart. Let's try a number less than 8. How about 7? 8 minus 7 is clearly positive. The first derivative positive, the graph's going to rise or increase. If you try something on the other side, like a 9 or a 10, 8 minus 9, 8 minus 10, those are all negatives. It's going to fall. That means that there is a relative maximum at x equals 8. Now, because the directions say find the relative extreme values, the 8 is not the max. This is very important. The 8 is the x-coordinate. The 8 is where the max happens. But the maximum value is what you get when you plug 8 into the original equation, which is what I have to do right now. So I'm going to figure that out. So the 8 goes in, and that's going to give us 64 minus 32 minus the 13 that's at the end. And that gives us 19. So the relative max, which in this case happens to be the absolute max because it's the only one, is 19. 19 is the extreme value. 19 is the max. X equals 8 is where it occurs. There's my official answer. 19 is a relative max. Sometimes you'll see College Board write it as the relative maximum of 19 occurs at x equals 8. If you say it like that, that way even if you accidentally answer the wrong question, you still said the information the right way. So, sometimes you'll see it written that way. All right, let's try another. All right, let's find some maxes and mins. First derivative. 2/3 out in front. Stuff to the go down by a power, so that's going to be to the negative 1/3. There is a chain rule times 2x. Tell you, man, chapter 2 never goes away. All right, let's see what that makes. I'm going to rewrite this a little bit neater. This 2 times 2x will be 4x. I'll dump the 3 to the denominator. And speaking of denominator, I have a negative power, so we're going to bring that down. It will be a cube root of x squared minus 9. And yes, x squared minus 9 does factor. We'll get to that in a moment. That is sort of significant. But I have to find my critical numbers. Now remember that critical numbers happen when the first derivative, here in red, is either 0 or does not exist. And typically, we set it equal to 0 and kind of forget about it because all the other problems I've done, were continuous functions. This one's still a continuous function, but if you were to graph it, there's going to be a couple cusps in it. And so there are places where the derivative does not exist, and you can see that down here. There are many places, actually, where the derivative doesn't exist, so we have to be careful. A great technique for finding critical numbers, especially when you have fractions, is to set the numerator equal to 0 and figure out what that is. And then once you're done there, set the denominator equal to 0 and repeat the process. All right, so we'll start with the numerator. If 4x equals 0, then obviously x equals 0. And so x equals 0 will become a critical number. All right, now let's see what's up with the denominator. If I set the denominator equal to 0, I think you can see that x equals 3 and negative 3 would both make a 9 minus 9 inside the root. So 3 and negative 3 will also become critical numbers. For a moment, I was worried about imaginary numbers. I was thinking, oh man, what if I put a 1 in there? I get 1 minus 9. But since it's a cube root, not a square root, we don't have to worry about imaginaries here. Sure, that could happen later on, but not in example number 8 here. Okay, time for a sign chart once again. Got negative 3, 0, and 3. All right, let's try each region. We'll start with negative 4. Again, I'm going to plug into the derivative. Inserting a negative 4 will give me negative 16 up top, which of course is negative. In the denominator, the negative 4 will get squared right away, so it's going to be 16 minus 9. That's the cube root of 7. I don't know what that is, but it's positive. So the overall derivative will be negative over positive. The graph's going to fall. All right, picking something between negative 3 and 0, let's try negative 1. That'll still give me a negative up top. But in the denominator, you can see that I'm going to have 1 minus 9 inside the cube root. That's going to be negative. And so it's going to turn the denominator negative. Negative divided by negative is positive. So if the first derivative is positive, the original graph is going to increase or rise. Continuing on, let's try positive 1. 4 times positive 1 will make the numerator positive. The denominator stays negative. So again, this will fall. And finally, last but not least, we'll try something larger than 3. I think I'll use 11. You can see this can be positive over positive. So it rises. So again, we have an alternating pattern. This will not always be the case. Don't you worry. You will soon see that I can break the pattern. But for now, it looks great. We'll find some values. We have a relative maximum at 0, at x equals 0. If you put the 0 into the original problem, you're going to get a big mess. You're going to get the cube root of negative 9 squared. You're going to get the cube root of 81 plus 7. And that's right about 11.3267. 11.327. Eesh. There you have it. Okay, more of the same fun. But this time we're going to have to deal with the quotient rule, as you can see. Again, more practice with chapter 2, the chapter that lives on forever. This will be the u. The x squared plus 1 will be the v. We'll need u prime v minus uv prime over v squared. I've already got my v squared written. U prime v will be 4x cubed times the v minus u v prime, and v prime will just be times 2x. So that's going to turn into 2x to the 5th at the end there, negative. And I have to set this equal to 0 and see where the extreme values might be. Again, normally with a fraction, you would set the numerator equal to 0, and then you would set the denominator equal to 0. I'm going to say right now that the denominator can't be 0, no matter what you try. Even if you try -1, it's going to get squared. You'll have 1 plus 1 squared. So you don't have to worry about that. It's not going to be 0. So we'll take the numerator and set it equal to 0. Before I do that, when I look at the numerator, I'm thinking I could probably do a little bit of distributive property and rewrite it, maybe even factor. We'll have to see what it looks like. Okay, so again, I got it to there. As I mentioned, it looks like the numerator can be factored. I'll take out a 2x cubed, meaning that one critical number will be 0. The rest will be x squared plus 2. And x squared plus 2 cannot be set equal to 0. It's impossible. So we're only going to get one critical number, and the critical number will be x equals 0. And if you plug the 0 back into the original equation way up there in black, it's going to be 0 over 1. So I know that it's going to be 0, 0. I just don't know if it's a relative max or relative min yet. I'm going to get my answer ready. I'll go as far as I can. I just need to put the last two letters on it. It's either going to be ax or in. All right, let's make a sign chart and find out what it is. Okay, if I pick something to the left of 0, how about -5? That's pretty crazy. And I put it into the derivative. Put it in right there. Obviously, it doesn't matter what you put into the denominator. It's going to get squared. It's going to be a positive no matter what. Okay, so we've established that. If you put the -5 up top, what am I doing? How about -1? Let's not go crazy here. If you put -1 up top, you can see that you're going to get -2 minus 4. That's negative. -5 would also give you a negative. All right, so the graph's going to fall. It sure looks like 0, 0 is going to be a relative min, but let's make sure. If it drops again and it's decreasing some more, then there wouldn't be any relative extreme values. The 0, 0 would be a ripple on the graph. Later on, you're going to see that we call that a point of inflection. But anyways, let's move to the other side. Let's try something like +5 or +1. I don't actually have to plug this in for you to see that that's obviously going to be bigger than 0. So if the derivative is positive, the slope is positive, it is going to rise. 0, 0 was, in fact, a relative min. Okay, as you can see, the directions have changed now. It says locate the absolute and relative extrema, so we want to know if it's absolute or if it's local. And we also have endpoints, where before we didn't. We were allowed to just go all the way to infinity if we wanted. But now, we're going to be sort of cordoned off between -7 and +7. Then notice that we have hard brackets on the -7 and +7. That means include them. A hard bracket is similar to a greater than or equal to sign, or a less than or equal to sign, where the equal to is underneath. If it had been curly, it'd be more like just having a less than or a greater than sign, not equal to. All right, let's try this out. Obviously, when you see extrema, that's a key word right there. That tells you have to take a derivative. So, of course, y will become y prime. And our derivative is going to be -6x squared plus 6x plus 72. I'm taking care of you guys by allowing things to be factored. So let's factor out a -6. That'll just be x squared. Let's see, I took out a negative, so that'll be minus x. And that's going to end up being minus 12. 12 times 6 is 72. That will further factor. Keep writing the -6. A lot of people don't like to write the -6 in front. I can understand why, because they're going to think, oh, you're setting it equal to 0 later. I can cancel it out. Algebraically, yeah, you're right. The problem is, when you go to do your intervals, you're only going to have 2 parentheses, and really there are 3 parentheses, and the first one is negative. The moment you don't write that -6, all your arrows are going to be going backwards, and you're going to be calling maxes mins and vice versa, and it's just going to be horrific. So please even though you can divide both sides by -6, don't do so when you're trying to find whether things are maxes or mins. Leave the negative number in front. If it's a +6, you can get away with it. No one will ever know. But it's not. It's a -6. So word to the wise. Okay, let's continue our factoring. It's going to be x plus 3, x minus 4. So the critical numbers will be x equals -3 and x equals 4. There's no x equals 0. This is a 6 out front, or -6. -6 cannot be a 0, so don't write 0 like some people do. So we're going to go ahead and make our sign chart. All right, let's test some regions. Trying something from the left region, let's try -4 in there. You're going to have negative, of course, times another negative, times a third negative. And that's going to be negative. That's going to fall. All right, let's pick something in the middle. I vote for 0. This will stay negative all the time. I might as well just put it nice and bold. Putting a 0 in the middle parentheses gives us 0 plus 3. That turns positive. But the final parentheses, 0 minus 4, still negative. Two negatives, however, multiply up to a positive. If the derivative, aka slope, is positive, you're going to rise. And finally, if you put a number in larger than 4, you'll start with the -6, but the other two will go positive. Both negative times positive is negative. It's going to fall. And so you're going to have some sort of a min at -3, some sort of a max at 4. But we also have endpoints. Oh, we have to be careful here. I'm going to go ahead and get my answer sort of partially made, and then we'll talk. Okay, I moved some things out of the way just so I have some workspace. Because these are hard brackets right here, we need to acknowledge that the -7 and the +7 might be absolute maxes or mins. Remember, the endpoints cannot be local or relatives. They have to be either absolute or nothing. They're picky like that. They're kind of snooty. So let me acknowledge it. -7 might be something. I'm going to go in order. So our critical numbers are next, the -3, the +4, and finally the right endpoint, +7. Using a calculator, I'm going to go ahead and figure out what the y-coordinates are, and I'll put those in now. Okay, there we have it. And then we have to kind of figure out what's going on. First of all, let's find the absolute max. I like to do the absolutes first. The absolute max would be either here at 4, because that's a max, or maybe in the beginning at -7. So we compare the two numbers, the two y-coordinates, I should say. And you can see that the -7 wins out. The 319 is higher than the 198. So therefore, -7, 319 is the absolute max, and the 4, 198 is just a relative or local max. Remember, the words local and relative are absolutely the same thing. You can use them interchangeably, so I probably will. All right, let's look at the minimum candidates. You can see that the -145 is 100 spaces lower than the -45. So -3, -145 will be the absolute minimum. And finally, it would be tempting to call 7, -45 a local min or a relative min. But remember, the endpoints, it's either all or nothing. If they can't be absolute maxes or mins, they refuse to participate. All right, fine, we'll just kick you out, kick you to the curb here. You are a nothing. You are not considered. And so the final answers are right here. We have an absolute max and an absolute min, and then another local max in the middle there. If you try to call 7, -45 something, if you try to call it a local min or an absolute min, you will lose some credit. So please don't get tricked there. All right, we're going to try another problem that has boundaries as well. And just to spice up your life a little bit, we'll throw in some trigonometry. Okay, some trig derivatives. Again, more review of chapter 2. Gotta love it. We'll start this problem the way we always do, with the derivative. 2 sine of x will become 2 cosine of x. And the cos of 2x will become negative. Remember, the derivative of cos is negative sine 2x times a chain rule 2, which I'll put in front. Okay, so we're going to set that derivative equal to 0. Now, unfortunately, the angles are different. You're taking the cosine of x, but you're taking the sine of 2x. And we can't deal with that, so thank goodness we know the golden sheet of trig. We're going to go ahead and change sine of 2x to sine cosine. That's going to turn this into 2 cos x minus 4 sine x cos x equals 0. Okay, at this point, I'm going to factor. I will factor out a 2 cosine of x from both terms. That's going to leave me with 1 minus 2 sine of x inside the parentheses. And of course, still equal to 0. Now, this is really important. Please do not do this. Some people are like, I'm going to divide both sides by 2 cos of x. Remember in pre-calc that sometimes when we did that, we would lose answers that are supposed to be there. And so, you really don't know. What if cosine of x is 0 and you're dividing by 0 inadvertently and you don't even realize you're doing it? So you cannot do that. Now, if you're trying to prove an identity in pre-calc, that's different. Then you can go ahead and whack that away. You can divide by cosine of x all you want. But not when you're trying to find all values. Okay, so leave it alone. All right, so you have two things multiplied together, and the answer is 0. That means that maybe 2 cosine of x equals 0. Which would mean that cosine of x is 0, of course. And again, from the golden sheet, cosine of what is 0? Well, pi over 2. Also 3 pi over 2. And 5 pi over 2, 7 pi over 2. But let's not get crazy. Thank goodness this is here. So we're just going to stop. All right, we have the other parentheses. That could be 0 as well. If that was 0, then you'd have 2 sine of x would have to be 1. I skipped a couple algebra steps, but please forgive me. We're running out of room. The sine of x would be 1/2. You divide both sides by 2. Sine of what is a half? Well, 30 degrees, which is pi over 6. But also you could be in quadrant 2. Sine is positive there, so the same reference angle, 5 pi over 6, which is 150 degrees. Quadrant 3 and quadrant 4, sine would not be positive a half. It would be negative down there. And I don't go any farther. Oh, wait a second. I disobeyed the instructions a little bit already. The 5 pi over 6 is okay to stay, but I don't know if you guys noticed this or not. This 3 pi over 2 is too large. I think I was thinking this was 2 pi. That's too big. That's out. All right, so the only critical numbers that we have, again, these will be angles because we're in trig, would be pi over 2, pi over 6. 5 pi over 6 is still less than pi, so it's still okay. And then, of course, we also need both of these endpoints, the 0 and the pi. They could be absolute maxes or mins, so we have to consider them. All right, so I need to go ahead and clear out some space once again. Okay, again, I took my 3 critical numbers and my endpoints, the 0 and the pi, and I'm ready to plug some things in. Let's go ahead and plug these in live, just because it's good practice. I'll start with the 0. Sine of 0 is 0. Cosine of 0 will be 1, so that's going to be 0, 1. Let's go down to the bottom next, because pi is easy. Sine of pi is also 0. Cosine of 2 pi would be the same as cosine of 0. That will also be 1, so pi comma 1. All right, let's go into the middle to pi over 2. That seems like the next easiest place to Try. I have sine of pi over 2. That's like sine of 90 in the golden sheet, which would be 1 times 2 in front, so that'll be 2. This is going to be the cosine of pi. Cosine of pi, remember cos is the x-coordinate, is negative 1. 2 minus 1, that is also 1. So I've got identical triplets here. All right, hopefully we'll break this time. I'm sure this graph is not a straight horizontal line, trust me. All right, we'll try pi over 6 next. The sine of pi over 6, or the sine of 30 degrees, would be 1/2 times that 2 will be 1. Plus cosine of 2 pi over 6, that's the cosine of pi over 3, which is the cosine of 60 degrees, which is 1/2. 1 plus 1/2 would be 3/2, or 1.5. I'll go with 3/2. And finally, 5 pi over 6. You're going to see that this is also going to give us 3/2. I'll talk you through the steps. This is the exact same thing as before. It's positive 1 because 5 pi over 6 is in quadrant 2. Sine's still positive there. Here, this is going to be the cosine of 10 pi over 6. And 10 pi over 6, or 5 pi over 3, is in quadrant 4, but hey, cosine's positive in quadrant 4, so it's still going to be 1 plus 1/2, just like it was before. Okay, wow. Just to save a little time, because this problem's starting to take forever, when I tried each region, I got that phenomenon, which is not surprising. This thing's going to oscillate between 1 and 1.5 every time. And so therefore, the 0, 1, the pi over 2, 1, and the pi 1 are all going to be absolute mins. Because it's a three-way tie for last, they all get to be absolute mins. And the same thing is true of the 3/2. It's a tie for first place. It's like the CVC. You could be co-champs. If we tie for first place with another school like Chagrin Falls, both schools get to put a trophy in the trophy case. Same thing here. Both of these can be absolute maxes. Okay, this will be the last one of its type. We're going to find the absolute and local extreme values, but this time, unlike the rest, you can see that the -6 is curled. +6 still with the hard bracket. That's going to come into play. All right, we'll start off with the derivative. We'll go ahead and set that equal to 0 eventually, but first we'll try to factor. You can factor out a 3. That will help. Again, since it's a +3, I don't necessarily have to write it, but I will. It's a good habit. Okay, good. We'll set that equal to 0. Oh boy, I can't use quadratic formula because it's cubic. It's 4 terms. This really tests your Algebra 1. This whole class does. The only way to further the factoring on this is to use 4-term grouping. You group the first 2 together, and you group the second 2 together. That minus belongs on the 8, so that goes in group 2. And you look at the first group only, and you decide, hey, what can I factor out? And the answer is x squared. So you do that, leaving you with 2x minus 7. Okay, you better be able to get another 2x minus 7 from the last 2, otherwise we're in trouble. And you can if you factor out a -4 or a -4. Yes, okay, so those 2x minus 7s match. So in turn, you can sort of factor that out. Got 2 parentheses. One is the thing that matches. The other is the junk left over on the outside, which would be the x squared minus 4. That's going to come down. Still equal to 0. And there's still a 3 that's been in front the whole time. And there's one more thing that we can do. That x squared minus 4 can be factored even more. That's difference of squares. That's x plus 2x minus 2. So I'll put that in. Okay, so we're ready for some critical numbers. The critical numbers will be x equals 7 halves, 2, and negative 2. All right, we'll make a sign chart. Okay, to remind myself that the negative 6 is not included, I'm going to curl that, and I will hard bracket, or just put a regular straight line on the positive 6, which is allowed to play. Let's label those. And then I'm going to go ahead and put my critical numbers in the middle in order. So negative 2, then positive 2, then 7 halves, which is 3.5, 3.5. All right, we're going to test things. So we'll start off with, I'm going to use negative 4, something in the first region. And the easiest place to plug the negative 4 in would be right here. Again, I don't need the equals 0. This time I really don't need the 3. There'd be an extra parentheses that would stay positive all the time. Who needs that? So I'll have 3 parentheses to look at. All right, in goes the negative 4. That's going to be negative times negative times negative, all 3 of them. So the graph's going to fall. It looks like there's going to be some sort of a min at negative 2, but let's make sure. Okay, so something between negative 2 and positive 2, I'll think of 0. If you plug a 0 in, the first parentheses will still be negative, negative 7. You'll have a 0 plus 2 in the middle, and a 0 minus 2 on the third one. That's going to be rising, because it'll be a first derivative that's positive. If you try something between 2 and 3.5, we'll try 3. You're still going to have 6 minus 7. That'll stay negative, but the other 2 will become positive. Negative times positive is negative. And finally, something between 3.5 and 6. Let's try 5. You can see if you put 5s in there, yeah, they're all going to be positive. So it's going to rise. Okay. So we definitely have some mins at negative 2 and at 3.5. There's some sort of a max at 2 and the endpoints. All right, it's time to write the answers. Okay, we've got some space cleared out. Let's put some answers down. Start with negative 6. And then the critical points in the middle. So we've got negative 2, positive 2, 3.5. And finally, the other endpoint, 6. Now, you are probably wondering, why did I use negative 6 up here when early on I pointed out that, it's got the curly parentheses. It's not allowed to be an answer. Why would I want to write it down? And I think you're going to see the reason in just a moment as soon as the y-coordinates are up. Obviously, to get the y-coordinates, you would be using a calculator. I do not want you doing that by hand. All right, let's check it out. We'll start with the absolutes first. I'm searching for an absolute max, and you can see by far the largest number on the board is 2,523. That was at negative 6, but negative 6 was ineligible. Dang. All right, so we're going to cross that off. I don't want to use that in my answer, again, because of the fact that it was curled. But if I made it up to 2,523 at negative 6, even though negative 6 is not allowed to be used, negative 5.9 is allowed, negative 5.99. And so, sure, I'm not getting all the way up to 2,523, but I certainly am getting up to 2,500. And 2,500 is way bigger than any of these other numbers that want to be maxes. So even though this is ineligible to be an absolute max, I cannot call 6,507 an absolute max. It would have to be a local max or a relative max. The same thing with the 2,91. I know that there's a max here at 2, but it's certainly not absolute because 91 does not beat 2,523. So that's simply a local max. Okay, now let's look at the minimum values. There are 2 places that can be mins. X is negative 2 and X is 3.5. You can see that at negative 2, you're at negative 133. Certainly that is lower than positive 74.9. So the negative 133 is the absolute minimum. And this other point, usually you don't think of a min being at almost 75 here, but 75 is a lot less than its neighbors 91 and 507. So it's going to be a local min. All right. I'm getting ready to circle my answer, and then suddenly I realize, wait a second. I am calling 6, 507 a local max? That's an endpoint. Endpoints aren't allowed to be local or relative. They're snooty. They have to be absolute or nothing. And so this ends up being nothing. If you include that in your answer, I have to deduct points. So this is all you want to say for your final answer. And again, you did have to try out this top negative 6 to realize that it was 2005-23. Let's say, just for the sake of argument, that it wasn't. Let's say that it came out to be negative 6, instead of this gaudy high number of 25-23, let's say it came out to negative 6, 200. It still wouldn't be allowed to be in the answer, but then suddenly this 507 would become the largest number in the whole problem. It would become an absolute max, and it would be allowed back into your answer. So even though this is not considered in the answer, you still have to investigate it. All right, hopefully that made sense. So those three: absolute min, local max, local min.